We've seen examples of how to take a number written in base 2 and convert it to base 10, but now let's practice taking a number in base 10 and then convert it to base 2. So 27, this is a base 10 number. We want to convert it to base 2. To do that, we're going to try and remove groups of 2 for base 2. Remember that the place values in base 2 start at 2 to the 0 power, 2 to the first, 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth, etc. We want to figure out what's the largest place value that we will need to write this number in base 2. To figure that out, we simply need to convert these powers of 2 into numbers that we recognize. For example, 2 to the 5th power, that's just 32. Now 32 is larger than our number, so that place value is off limits. 2 to the 4th power, however, is only 16. 16 is small enough to work with our number, so in order to use base 2, we can use this place value. This is the first of the place values that work, or the largest. So what we're going to do is figure out how many times that 2 to the 4th power place value fits inside of our number 27. There's a cute little way to organize this, and that is starting with our number in base 10 and then drawing a little house around it. We put the place value for the new base on the left, and then we kind of write this like division. How many groups of 2 to the 4th power fit into 27? Well, 2 to the 4th power is actually 16, so we can look at 27, subtract 16, and we can see that only 11 would be left over, which means we cannot subtract another group of 16. It only fits once, so we put a 1 here. So remember, the original number goes in the middle. The new base place value goes on the left, and how many times it fits goes on the right. And then we build on this. So 2 to the 4th, we said, was 16. It fit once, so we multiply the numbers on the left and the right, 16 times 1, and we subtract it from the middle. And then we build a new house around that number. We had 2 to the 4th power, now we're going to decrease that to 2 to the 3rd power, that's the next place value. 2 to the 3rd power is equal to 8. We can see that 8 will go into 11 exactly once, and then we'll subtract 8 from the 11 in the center. And then we build a new house. The next place value is 2 squared, which is equal to 4. Now 4 won't fit into 3. 3 is too small, so I put a 0. I would technically subtract 0 and bring down the 3 and build a new house. The next place value is 2 to the 1st power, which is just 2. 2 fits into 3 just once. I subtract the 2 out, and I'm left over with 1. And then we build a new house. We're at our last place value, which is 2 to the 0 power, which is the same thing as 1. 1 fits into 1 once. We can see that subtracting it off would leave us with 0. And now we go back and we pick out the base 2 digits. So all of the digits on the right side represent the groupings in base 2. And they're in the appropriate place value. So I have 1 in the 2 to the 4th place value. I have 1 in the 2 to the 3rd place value. I have 0 in the 2 squared place value, 1 in the 2 to the 1st place value, and 1 in the 2 to the 0. And that makes up our number in base 2. And if we wanted to confirm that we had this correct, we would just write this in base 2 expanded form, which would be 1 times 2 to the 4th plus 1 times 2 cubed plus 0 times 2 squared plus 1 times 2 to the 1st plus 1 times 2 to the 0. Type that into our calculator and you will get back 27. So again, the process that we used here was we said, all right, we're starting with a number in base 10. We want to convert it to base 2. So let's list out the base 2 place values. We're going to start with the biggest place value we can think of. Well, we can think of higher ones, but we'll start out with a place value. And if it's too big, we'll move down. Now, on the other hand, if we had started with a place value that was too small, for example, maybe we started with 2 cubed. 2 cubed is 8. 8 fits into 27 a whole heck of a lot of times. In fact, if we do 27 divided by 8, we'll get 3.375. 3 is not allowed in base 2, so I know that I could have used a larger base. So I would have needed to check up one place value higher. We want to pick the place value that's the largest place value that we could possibly need. If we went with one that was too small, we wouldn't end up getting the right answer. So you need to check a couple of place values. You can confirm that you're at the perfect one because the place value up would be too big and the place value below would be too small. Once we picked the largest place value that we needed, we created this little house system that took our base 10 numbers and rewrote them as base 2. And once we got down to the end where we got 0 at the bottom, we knew we were finished, and then we just extracted all of the base 2 digits on the right and kept them in that order because that keeps the place value consistent. For this next example, we need to know what the Duodecimal system is, which is base 12. Now, in base 12, we should have 12 digits. But our digits, 0 through 9, kind of fall short. That's only 10 digits. So we have to create 2 new digits. We'll use T to represent 10 and E to represent 11. Now, I do not need a digit to represent 12 because in base 12, if we have 12 items, we just move up to the next place value. So we are given a number in base 12 and we want to convert it into base 10. So the first thing we'll do is write that in the expanded form. We will have E times 12 to the 0, 1, 2. That's the 12 squared place value, plus 2 times 12 to the first place value, times plus T times 12 to the 0. Notice that my place values are powers of 12 because this number is starting off in base 12. 12 squared is the same thing as 144. 12 to the first is just 12. 12 to the 0 is just 1. So we could write this as E times 144 plus 2 times 12 plus T times 1. Now, since we're going from 12 to base 10, I can replace E with what we use in base 10 to represent 11. And I can also replace the T with what we use in base 10 to represent 10. And then from here, it's just calculator work. We'll type in 11 times 144 plus 2 times 12 plus 10 times 1, and we get to the base 10 numeral, 1,618. If we want to take a base 10 number and then convert it into base 12, we're going to use that house notation that we used in that first example. But first, we need to find the largest base that we will need to represent this number in base 12. So let's do 12 to the 0, 12 to the first, 12 squared, 12 cubed, 12 to the fourth. Hopefully that's enough. So let's try 12 to the fourth power. 12 to the fourth power is 20,736. That is too big, so we'll go down. 12 cubed is 1,728. And that's just a little bit too big. Remember, we're using 1,200. 12 cubed is 1,700, so still too big. 12 squared is 144. That is small enough to fit inside of our number. That's the largest place value we need for base 12. So when we start our little house notation, we'll put 1,277 in the middle. We will put 12 squared on the left, which we know is the same as 144. And then we need to figure out how many times does 144 fit into 1,277. And we can use division to help us with that. If we divide 1,277 by 144, we get 8.86 other digits. All we care about is the whole number piece. And that's because we can write 1,277 as 8 times 144 plus some remainder. So the 8 is what we will copy down over here as our base 12 numeral. And then we'll subtract 8 times 144 from 1,277. So if I do 8 times 144, I get 1,152. That's what I need to subtract here. And I'm left with 125. And I'll draw my new house around that. The next place value is 12 to the first power, which is just 12. Maybe we remember that 12 times 11 is 132, so that's too big. 12 times 10 is 120, so we know that this will fit in 10 times. We'll subtract the 120, have 5 left over to draw a new house around. Our next place value is 12 to the 0 power, which is just 1. 1 fits into 5 times. We have a 0 on the center, which means we're done with this algorithm. Now all we need to do is go back and pull out the numbers. Now in base 12, we can't write 10. That's a base 10 digit. So we would replace that with a T for 10. So the number 1,277 in base 10 turns into 8T5 in base 12. Let's try one more problem. This one's a little more of like a puzzle than a pure conversion from one to the next. But these types of problems really will make sure that you understand the difference between, say, base 12 and base 10. If we want to know what digit would belong in this third place value of a base 12 number, so that it's equivalent to the number 1050 in base 10, what we need to do is kind of do a process of elimination. We're going to start by taking this base 10 number and turning it into base 12. If you remember, base 12, if we're starting with a base 10 number, we look at our base 12 place values. 12 to the third power was 1,728, so that's too big. We will start with 144, or 12 squared. We'll take our number, 1,050, put it inside of that little house format, We put our 144 on the left. We find out how many times it can fit into 1050 by doing division. I get 7 with the remainder, so I know it'll go in 7 times. 7 times 144 is equal to 1008, so that's what I'm subtracting. If I do 1050 minus 1008, I'm left with 42. So I build my house around that. Our next place value is 12 to the first, or just 12. 12 goes into 42 3 times. 12 times 3 is 36. 42 minus 36 is just 6. So we build our house around 6. Our next place value is 12 to the 0 power, which is just 1. 1 goes into 6 times. We subtract off the 6 to have 0. The 0 in the center tells us that we're done with this process, and the digits that we have on the right are what we would use to write this number in base 12. So 736 is the number in base 12, and it's equal to 1050 in base 10. So if we match this up to G36 in base 12, we can see that the G would have to be a 7, so that it's equal to 1050 in base 10.